All right, you want to verify that we are going?
Yeah, it'll take it just a second to kick in. Okay, we're good.
So we're doing some image analysis of this. Yeah, Jeffrey called out that there's sort of a Nicolas Cage face-off thing going on for me here. I was a little proud of my Yoda ears. I think I did a nice job marrying the Yoda ears in. The original AI prompt was sort of, because we're going to do rate limits. So for some reason that made me think, rate limits and two people made me think of like the I Love Lucy's thing. And then we put some
Oh
rubies
yeah,
in here. So,
that's a great rate limit metaphor, actually.
yeah. All right.
Are we supposed to start eating the rubies as they fall off the
Exactly. So
conveyor belt?
we're gonna generate a rate limit client that eats all of the chocolates as they go by, in some way,
Oh.
shape, or form. Uh, Welcome back, Jeffrey. How are you? How's your day?
It's going. I almost my favorite answer to like how's it going is there's this quote from Liar Liar with Jim Carrey where he famously cannot tell a lie, and so someone asked him how it's going, and he immediately, without pause, says, "I'm a little upset about a bad sexual experience I had last night." Um, and so the temptation is to always go there, but instead I just tell the entire bit, and yeah,
All right. Well, next time, now that our listening audience understands, when you do a
sure,
callback to that later, we'll know just what happened.
love it, love it.
All right. So we're gonna build a basic little rate limiter, a toy here, but in Ruby because rate limiters are fun. I love rate limiters so much. I once tried to start a company called ratelim.it, which was fun. And Jeffrey, you said you've built one once upon a time.
Yeah, I think it's a fun, as you said, it's just like a fun experiment, like a little code kata or something just to practice.
Yeah. Um, and so I was thinking about it, and I think a place to start would be like, how are we gonna output that this thing is working in a kind of fun way? And so I was thinking, I screwed around with something last night to just sort of have like something sort of printing out in a loop, and then it'll just print out one thing if it passes and one thing if it doesn't pass. So maybe
Okay.
we just even start there with a sort of a fake, and then keep and then make it real.
Yeah, yeah. Let's give that a try. It's always good to have a visualization.
All right, so I was doing a like I was so what times do nope, that's not how that works. So
There
I
we
was
go.
thinking of this, and then we'll just put it we'll put something like if it uh like limit dot pass, we'll print a, otherwise we'll print like a dot. Yeah.
Okay.
And then
Yeah, that works.
sleep like a little bit. Dig it?
Yeah, I think that makes sense.
We're gonna need a class. We're gonna need a class or let's just call it a limit, and it should have a method. And so we can just be really scrappy and do. Should it pass or not pass?
Mhm.
True. Okay. And then we'll do the limit equals a no. All right, let's see if that works.
I love that you have the same. Hey, that works perfectly. You have the same polyglot experience that I do, which is the first time I start typing in a new file type for the first time in a day or so, I just using all the wrong idioms. Uh, it's great.
That would probably be the AI programming tool of choice, is that I can just sort of write in Jeff and it comes out just sort of
Yeah.
directly in whatever language I was in at the moment. Yeah, I
Maybe that's really the future, right? Is like there are no programming languages anymore. It's just all your own personal idioms and idiosyncrasies, and then the it's like a million coffee scripts.
copy. It's always been CoffeeScript all the way down.
Yeah.
But yeah, I sort of I feel like I don't know any languages. I just sort of
Hmm.
generally have kind of know how to program and then slam things and Google furiously until it fits.
Absolutely. Sometimes the stack trace driven development works out pretty well.
It's been a long career of it. Um, All right. So that passes all the time. So sometimes it shouldn't pass. Um, and I think, I guess we just sort of get into it here with like what a rate limiter is and
Mhm.
how we want to think about it. Um, so you did you use the words token bucket and leaky bucket and those sorts of things?
Definitely familiar with leaky bucket. Token bucket is one of those things that I have a vague sense of what it is, but I would not want to, explain it in front of an audience.
Interesting. So yeah. So what? Can you explain leaky bucket in front of an audience?
I could try. You can correct me if I'm wrong here. And I actually hate the metaphor of a leaky bucket because I think it's a pretty flawed metaphor. But um, I think generally speaking, and again, jump in here where I'm dead wrong, the idea is that you have a container, a bucket, that can accept some maximum size of things. A bucket can only hold so much volume.
Hmm.
And the bucket has a leak, which is to say that things come out of that bucket at a fixed rate, or at least a maximum rate. They can't overflow with high pressure, so there's some limiting effect on that. And so it's useful in the concept of rate limiting in that if you have suddenly like a lot of background jobs or other things stampeding, that's fine. They can sort of congregate in the bucket itself, and then will be doled out and dealt with over time at a predictable pace.
Yeah. So sort of um, an interface a little initialize. That's good. Thank you
Close
for the
enough.
spelling. So sort of it's got like the rate or something
Hmm.
rate per sec just
And that's like the flow coming out of the bucket.
and then in general like the interface to then it sort of like typically has like a queuing size right or something. It's like you put all the things into the rate limiter and then they sort of like leak out at the right rate. Yeah.
Right, right, right. So yes, the strength of the flow or whatever, if you want to keep pushing the metaphor.
The strength of the flow. Yes. So that is yeah. So that's leaky bucket. So I think the
The,
issue that I've had, I think the issue or the funny thing with a leaky bucket is that there is this like behavior of like how many things it wants to store before it can like fully overflow, and you sort of this it's kind of this in memory challenge. If you just send too many things at your leaky bucket, like it's gonna explode, right? Because it
right. And I think that's where the metaphor gets really stretched for me is like I know what happens in the real world if I pour too much liquid into a bucket, but it doesn't play out that way. The metaphor is broken at that point, I guess.
or sort of when I think it kind of works, it's like you're dropping packets. You're just never gonna.
Yes, I guess it depends on where the leak part of the bucket is going, because now it's like, oh, everything's leaking.
Yeah, right. It has to like leak into the it leaks into the good bit instead of the bad bit.
Right,
Yeah,
right.
there's a difference.
Anyway,
Um, so when I've thought about it, I am a token bucket fan because the it makes me nervous to have the object sort of like keep track of all of these things, and so the token bucket thing is basically you can just sort of ask the question like, will I pass right now? But you don't need to keep track of very much. And so the token bucket is just a bucket, and it doesn't have a leak, but you can take things out of it, and all it has to
mhm.
remember is how many tokens are in the bucket, and you can take things out if there's anything in there, you're allowed to take it out, and then the bucket refills at some rate.
Hmm.
Yeah.
Yeah, so that the way you described it was kind of more, I guess, more from the um, you're taking stuff out of the bucket. How do how does the stuff flowing into the bucket work in this scenario? Like, how do you is
Yeah.
there a limit on that, or how does that
Exactly.
work?
And so the cool like I think the cool aha that I had with it is it sounds like it's like okay, we're gonna have this object where you're like at tokens, and that'll be that starts off as zero or something, and pass is going to be something like tokens minus if tokens is greater than 0, true tokens minus minus, and true else false, kind of this thing here.
Okay,
So
so let me just try to rephrase this to make sure I understand it. Um, so is this sort of with the leaky bucket, you are sort of asking for forgiveness. You're just throwing things in there willy-nilly, and you're just trusting the bucket to do the right thing. With the token approach, the token bucket, it's more of asking for permission.
yep.
Okay. So you would check the pass, and then if it's good, you do the thing, which may be like I guess it could literally be anything. Okay. That
Yep.
makes sense.
Yeah. Um, and so then the question is just like, how do you refill the bucket? Because we're not refilling it right now. And
Right.
the what I think the neat aha, which isn't too brilliant, but like it sort of feels like you need a background thread to like keep putting stuff into the bucket.
Mhm.
But what it turns out is you can actually it you're putting things in at a constant rate. And so you can just figure out if it's been 60 seconds and I have a 1 per second, I should put it in there. So you can actually kind of do it lazily. So you can do like refill tokens here before you call, but before you call it. And then this, you can just do a little math here. You can say, we'll do at tokens plus equals the yeah, so we need one other thing. We need last refill time. Oh, good number.
Okay.
Time dot now, and then we're gonna say last refill time equals time dot now, and tokens. What are we gonna add? We're gonna add time dot now minus the last refill time.
Okay. So we have some number of seconds.
Yep. And then if it was, I think this will just be times rate per second. So check my math. If it's 10, then,
Mhm.
and it's been 20 seconds, then we will have 200. Yeah.
That seems reasonable.
Seems reasonable. It's easy to get that a little bit wrong. But let's see. I think this could conceivably work.
Right.
Uh,
So we need to initialize with our number here.
so what will be fun? We'll do 1 per second.
Okay.
And then, so we would expect an A every 10 or so. Yeah?
Right. Right. Roughly. Yeah.
Boy, I wonder what will happen.
Oh, we got an error. I think you want to like slap a 2F or a 2I on those parens.
On these guys? Because the. Who got.
Yeah. So
Oh,
you're
yeah,
doing
dot, dot. Like that? Or actually, maybe just time dot now. I
um
can't.
nil can't be coerced into a float. Oh, the rate per second isn't getting memoized in the beginning. That's the problem.
Nope,
You're
there
not
we are.
setting it to an IVAR, so we're trying to multiply time times no.
That's good too. I
Nope,
think.
that's not right.
Oop, that wasn't me. I tried to do the right
Yeah.
thing, and I think I fixed it. Oh, look at that!
That's perfect.
It's satisfying too.
It is. It really is. It's almost like a Matrix style. It just needs to be green and I guess have a lot of fancy characters.
Yeah. So, ooh, we could try to. So here, yeah, and I was thinking it would be a little bit more fun here. Say we make more of these, so we can have a couple. And so maybe we do a little. I got. So let's call this, and it has sort of like let's move this A into a thing here. So like kind of like this. And a B, and it has B goes faster.
Sure.
All right. So
I am baffled that you chose to make the object be the key in the hash here rather than having the A and the B be the key. But um,
I think that's a
there's nothing
fair.
wrong with that. It's just sort of is like my brain would never get there. Uh,
I
it's
don't.
perfectly valid. It's just not where my brain would get.
No, I think that's fair. This is the thing, and this is the limit. I think that this is standard kind of human style.
Yeah, yeah, that would be fixed in the Jeff translation, I guess.
All right, so I want them printing out like matrix style next to each other. So limits. I can map over these guys. And that's gonna be like a key, the key and the limit, right?
Mhm.
And maybe we just return. So then we do if, or so we can do limit pass, and we'll do the key, else
Mhm.
the period.
Okay, that makes sense.
We could um, results puts the results join something.
Yep.
Yeah, maybe. Ooh.
It's interesting that can you stop it or scroll it to the beginning of the input or yeah, whatever, start it
Yeah, I
again.
think there was some interesting stuff there.
So at first it is not doing anything.
Yeah, I would expect.
That's not what I would expect.
I agree. So, yeah, so at first it didn't do anything, and then we're really filling it up like all five are going in, and then it's empty. So these aren't even, right? It's not like we're getting the five to come out evenly.
Mhm.
Let's see why that's the case. All right, tokens. Okay, so that's because we set tokens to 0 at the start.
Right, but we do a refill tokens. Oh, but that's based on the time since start. Okay, well that makes sense.
Oh yeah, that's kind of fair, I guess. Um, and then the time since start, and then is it then? It's interesting to me that I think I expected these to come out like every few,
Mm.
instead of in a big bunch. Why is that? So,
I think the problem is our 2i
hmm.
is so we're sleeping for zero point 0.1 seconds, right?
Oh yeah,
But our 2i is going to make this so that you're going to have a 0 on that time.2i minus last refill time. Let's try getting rid of that 2i and see what happens. Well, all of the 2i's, I guess.
yeah. I fixed a non-bug or something there. All right, let's do that.
Oh, yeah, maybe get line 35 also.
Yep.
Okay, so then we do need to, thanks to our error message
Mm-hmm.
here, let's throw like a 2. Can you add a float number of tokens? I think the answer is no, right?
Can we? Well, yeah, it's a good question.
Although I guess that would smooth out over time.
Yeah, it's not.
Should line 25 really be if tokens is greater than 1? If we're going to be, if we're, it was fine before, but if
Yeah.
we start using fractional tokens, I think we do want that.
If it's like
And
greater than
then,
or equal to 1, now we can subtract
yeah,
1.
and then
Mm-hmm.
on line 34, I think we can 2f on the parens there. Um, so we'll do the math and then multiply the fractional version of that,
I think I'd
the
also.
float version.
My other instinct is to go to millis. Hey, that
Oh,
worked
this
out.
is looking much better.
That's what I expected.
So now we're getting that nice drip.
Yeah, absolutely. And actually, this is interesting too because there's another concept which is kind of handy. There's another thing that can be useful here,
Mhm.
which is that the capacity can kind of be different. So with this can if we do actually capacity, I'm just going to do the capacity equals 0, and then we'll get the normal behavior here. But what you can then do is, let's add in C here. And it has, sometimes there are APIs where like, yeah, sort of constant usage, you want to be below a particular thing, but you can also kind of burst for a little bit. And so this kind of gives you burst capacity here. So I think we just give ourselves some burst.
That's cool. And so this one also should have, it's running straight from the start.
And then after 50 or so, I think it's going to stop and go and be the same as B. There it is.
Amazing.
Yeah. Look at them just in lockstep like that. Good little rate limits.
If only everything were that orderly.
Well, I think that one kind of swimming. So yeah, the bit I like about this is that, so this is in memory here, but you can see we're storing hardly anything, right? We're just storing the number of tokens, this number per second, the last refill time. It's like not a lot of information. So this, we've kind of pushed back the function over to here, which I think is a better place for it. We've pushed back the thing that the leaky bucket does is it sort of blocks for you, and so you could still get blocking behavior from this, but you sort of need to bring it yourself and be responsible for it in your own queue or something. Or I mean, we could put that in the limit thing here. Have a block.
Yeah, that's what I was going to ask. This is definitely a naive question because I haven't thought about this in forever. But if this was less of like asking for permission and more of a like, conditionally do this thing, like we gave it a block of some work, I guess the problem is then the control is all internal, and you don't know what to do if it can't handle the capacity right now.
Yeah, so it's basically block or don't do it, block or drop, and so yeah, it's like those are both reasonable options in certain cases. So pushing that out one layer from the actual limiter, I quite like.
Yeah. Right. So then you could have like a blocking limiter or a dropping limiter that sort of builds on top of this and maybe has that cleaner API where you're just like, do this thing. And yeah. Okay. 100%. That makes a lot of sense.
The other cool thing, so you can also see why this is so good, why this works really well in like a Redis or something. You can make, this math is very simple, and you can put in like a 2-line Lua function, which is basically, if you're using like a Redis rate limiter, it's nothing much more than this. It's just a little bit of Lua to do these things in a teeny weeny little transaction there. But it's really not storing anything more than this, which is cool.
Right on.
The other thing which is kind of neat is, and if you build this like sort of more distributed, then you can also, basically based on this math, you can also, or kind of similarly, you can calculate like when's the next time this is actually going to pass. So for something where you really, for something where fairly often you're going to reject things and you want to be able to cache that elsewhere, it's sort of perfectly safe, except for maybe clock drift or something. You can say, don't call back until, it's like, we're definitely not, we will not be back with you until sort of the math will work out for this. And so you can kind of send back a cache until kind of thing, which is kind of cool.
That is cool. I've definitely seen that with things like, I think Stripe's API, they set that in the headers of like, you're over your limit until this time.
Yeah. Right, exactly. Yeah, then the 429 you get the all right, so that's fun. Any other things you want to take a look at? We could try and make these dynamic, which was a little fun.
Yeah, I think that could be interesting. How would one even go about making something dynamic?
How would they? Well, if only we'd. So, at the risk of shilling prefab, where Jeffrey and I do work, it is fun. But so we have dynamic configuration, so you can. I think I plugged it in here so that we've got prefab, and we can do get. So if we say like here, this rate limit A rate, and I can hover over it, and you can see that it's 1, and I could make rate limit B rate here, and that one's 3. So the cool thing, these numbers are stored on a server and then pushed out over SSE to this here. So the idea is that every time you call this, it's hitting an internal representation. But if we go and we kind of edit it, and so we could change it to 5 here.
You actually want to get
Yeah, pick the default environment and then go to 5. And then presto changeo, the next call to this will be a 5. So what we need to do this is we'll need to change it a little bit here. We sort of don't want to push in our numbers here.
Right.
I think we want this to kind of look it up. And so my idea was to have it kind of look up by name, where we look up the A or the B.
That makes sense. I guess the other thing you could do, I'm not advocating for that here, but just sort of thinking about generalization, is have the rate per second be like a proc or something. And then in this case, that proc could return.
Oh, yeah. That's fun.
Evaluate the prefab get. In other cases, maybe it's just a number or some, calculation.
Yeah, we could do that too.
But I'm fine with the key right now. I'm just sort of
all right
pontificating.
No, that's good. So okay. Well, yeah, we'll do the rate limit A style here. Rate limit B. I'll get rid of this guy for now. And then it's sort of an extension to the ones I had created before were sort of like this and then dot capacity. So now this is going to come in and we're going to have a name here instead, yeah?
Okay.
Maybe we can just define... let's forget about capacity for a second, just to simplify our lives. Okay. Let's define rate per second as a functiony here. And we'll do this, except this bit here will be the at name, and we'll at name equals name. This doesn't exist anymore. We got a red thing. I gotta update
our dev tools to not prompt there.
Yeah.
Creating a config that has an interpolation is a whole animal.
Didn't see that coming. Yeah.
Yeah.
Pushing the envelope. That seems all right to me. So A is set to 1, B is set to 5. I think that's actually what we had set.
So we're only using the capacity, not the rate.
Oops, that's not the one I wanted. Yep, you're right. Rate.
Okay.
This might work.
Okay. Let's give it a go.
All right. Oh, we should initialize our library.
Oh, yeah. Fair enough.
Fair enough.
It's a fair cop.
That seems about like right. The same thing, but now for all the marbles, we can default. We can pump it up to 10 times per second.
Oh my gosh! Look at all those A's.
That's quite satisfying.
It really is. And especially once you imagine it outside of just your local host, so this could be, clusters of things that are suddenly changing behavior.
Yeah, absolutely. Yes. So what's happening under the covers is there's a map basically in here of this to the value, but then the SSE connection, the server sent events is updating that when it gets a new event.
Right. And just to put a little more pepper on that gumbo to emphasize it, the prefab.get is a purely in-memory lookup. There's no API calls happening here. It's it's a little more complicated than just fetching it directly out of memory because we enable things like rules and evaluating things based on the context of the current user or machine. But it is about as free as you can get.
The internet can be our guide for whether we accidentally turn this into a sales call, Jeffrey. But it's just fun. It's just fun.
No, yes, it is.
Yeah.
So Jeff, I mean, This is the problem with making things dynamic is that every time you see somebody restart a program for a reason, you're like, how do I make that dynamic? And
How do
so
I
you
do the right
recently,
thing
you
here?
just added C in here.
Yeah.
Um, so obviously, like there are ways to write this software such that the limit names themselves are managed by a different piece of live config, and then you could spin up a billion of them if you wanted. Well, we will not do that now, but
Yeah, yeah.
it's sort of like this. It's kind of like the when
I
you have
like
a
it.
hammer, everything looks like a nail, except it's not a hammer. It's like a nuclear weapon or something. Well, no, that's not a good example either. It's a very powerful tool.
I hadn't looked at this before, but the evals are kind of. I've just been screwing around with this previously, and I'd made all these
Yeah.
ones. It's kind of fun. Done it 2,400 times. Um, grand. All right.
Was there anything else you had up at the top that was interesting fodder here?
Yeah. Let's see. Um, the cool unlock. I just meant the sort of the idea of not tracking those things and doing this sort of the refill
Yeah.
tokens here, which is neat. Um, this is so we did dynamic. This is not thread safe here, which would not be a big deal to do. We just need to do. I think we need to do the refill tokens and the token subtraction. Uh, you know, atomically.
Right. And I know that in the past, or even still currently, we reach for concurrent Ruby, which has some really good primitives for that to get this stuff going.
100%. Yeah. I think you could try to roll your own with a mutex and other sorts of things, but don't don't do it. Concurrent Ruby is really good.
Yeah.
So that's always good. So yeah, we could do you could make it thread safe. I think the other bit was maybe we could just start advancing our concept of sort of what like a limit definition is and whether it's these are all sort of per second, but we could also
Mhm.
sort of have it things. Oh yeah, it is. These are all per second and per minute or per second, like rolling, right? They just sort of
Mhm.
roll, which is makes a lot of sense for per second. There are kind of interesting cases where you might want like per month, but not rolling. Where you want
Right.
you actually have like a hard like rate limit from some third party service of 10,000 per month, and they really you want them to like happen on the month boundary, and so
Yes.
I think you can kind of do that with with different logic around just when to refill by having like a
That's interesting. Are you aware of any of these sorts of things that have sort of a hybrid model there of it sort of renews as you go up to a cap or something? It feels like there's a lot of ways to orchestrate this and make it really out of control.
one really interesting use case that was solved in the sort of the service that we had at HubSpot was when you've got multiple rate limits. So you have to be 10 per second, but you can be 400 per minute and this per month.
Right.
So like the Twitter API, there's a bunch of different ones. You can't burst over this, but you're allowed to do this much in this time and sort of these other things. And that is interesting. So it's a little tricky there is you've got like three rate limits. So we could model all three of those. But then what you want to be able to do, if any of them say fail, you want to fail. But the thing you do want to be able to do there is if you if you ask the first rate limit and it says you're good to go, and then you ask the second one and it says nah, you want to probably return the tokens.
Right. Recredit the first one.
Yeah, and so that's a fine thing to do. You can easily have a return the token thing here, right?
Right.
So the sort of core, I think, of something like that is you can do pass is really just a simple case of acquire tokens where the count it sort of has a default count of 1 or something, but there's no reason you
Right.
only need to get 1 token here. So you can do things in in a bigger system, where you're trying to go really quickly and the rate limit is 500 per second or something, and you have 100. You've got 100 things to do. Rather than hit the service 100 times, you can say, "Hey, give me 100. I'm gonna deal with the. I'm gonna use those," and then so you can have that. You can acquire more, and then you can also return something if you're not using it,
Right.
which is kind of interesting.
That's fascinating. It feels like at some point, if you had to do a whole bunch of that complicated stuff, you would eventually want almost like a transactional. I have these 3 rate limits, and so rather than like borrowing and having to return and all that sort of stuff, you have this thing where like only if all of them are in agreement, do you deduct them all at once from all of them or something. But
Yeah.
that's fascinating.
Yep. That's yeah. Having that sort of just magically work is a super cool feature. I think the other thing is once you've built return tokens, there are some. So here's a super crazy thing. If we say the tokens is 1, and we say the rate per second is 0, you would think this sort of isn't a rate limiter anymore, and it's kind of not. But what you have here is a semaphore, right? You call it, you take the token out of the bucket,
Right.
and then you can return the token. And so now you've got like this distributed semaphore where people are taking the tokens out and putting it back.
Right. It's almost like a community bank where you have to put stuff into it to be able to take stuff out of it.
Yes, we're all working together.
Yeah, you built this whole economy now.
This is
I like this.
this is so yeah. That semaphore thing is super useful. It's you're like for whatever reason I don't want these jobs. There are instances where many of these jobs could try and do the same thing at the same time. I would like to prevent that, make them get the token out. But also there's sometimes you're like, for whatever reason, many jobs will start. I would only like 3 happening at once. So now they all have to sort of agree on that. Of course, anytime you start doing that, if one of the trouble scenario there is if they die before they return the tokens, and then you're sort of in a token exhausted. The community bank has run dry.
I'm picturing the Monopoly guy with his pockets turned inside out, looking really, really sad.
So that's kind of a fundamental thing. I think their best ideas to solve it are just like something else that kind of checks where you can be like, hey, it's been this long and like it didn't come back. Like I kind of want to I'm gonna declare it dead, but there's sort of
Yeah,
a tunable
you almost need
safety
like
there.
a brokerage or something. You
Yeah.
put the money, you put the tokens in escrow. Uh,
Yeah,
yeah, that's fascinating.
but it does seem like
It does.
Okay.
Go ahead.
No, fundamentally, it seems like there's like you have to have a arbiter or that escrow agent who decides what happens if no one ever picks it up out of escrow, like what happens. So it's
Right.
it's a funky case.
I guess I imagine there's still those are sort of extreme cases, right? There's still plenty of cases where just like, oh, okay, so we're not able to do as much work now because we dropped some tokens or whatever, is a perfectly fine solution.
Yeah, yeah. It just
This
yeah, exactly.
The rate limiting stuff I think is fascinating because much like live config, once you start thinking about it, you see how many problems are really rate limiting problems. So for instance, idempotency with sending emails. I remember at HubSpot, that was a big thing, right? Like you didn't want to accidentally send the same email to someone twice. So that's kind of itself is a rate limiting problem where the key, I guess, the thing that you're rate limiting on is some unique identifier of the email and then the unique identifier for the destination, the target of that email, right?
Yep. And Yeah, so that's sort of kind of similar to this case here is like you don't, this is kind of a once per ever. You want these
Right.
semantic, like, can I send the email? And you want this to return yes, and then you want it to return no forever. So yeah, thinking of it as a rate limit, it doesn't sound like a rate limit, but once per infinity. Um, and then the good news being that sort of the only data you need to store to enable that use case is just like current tokens and like the last refill time, and that's not a lot of bits. So you can kind of hang
Yeah.
on to that infinity, that item potency forever.
Fascinating.
Cool. Ah, we built something fun.
I like it. Let's call. Why don't we call it there? Thanks for
Let's do
hanging
it.
out with me and talking to me about rate limits.
Heck yeah. Heck yeah. This was fun. All right. Thanks, Jeffrey. We will be back. We'll be back at it.
All right.
Thanks.